All right, good afternoon, you scholarly eighth graders. Hope you had a good Monday. Today we're going to spend a couple minutes and do some notes on algebra, specifically like terms. So today is October 28th, 2013, and if you want to go ahead and number this page 18, that's what it'll be for your notes. The last page that you have in there is page 16. But on Thursday, you had done a lesson from the book. So we're actually going to take that lesson out of your book and call that page 17. So that way this one can be page 18 and all your notes are together. All right, so before we dive in, we need to just make sure we're good on a couple vocabulary terms. So the first one is actually what is a term? And in algebra, that is a number or a variable, or it can be a number times a variable, or a variable divided by a number. Um, so for example, here we've got 3x squared times y. That entire thing is considered a term because it is a variable times a number. Um, so I should probably move this arrow to say that that entire thing is a term. All right. Coefficient, that would be the number in front of the variable. So using our example over to the right, that 3 is our coefficient. That's the number that comes before the variables. All right, so we got term down, we've got coefficient, and now we need to talk about like terms. Like terms are any terms that have the same variables raised to the same exponent. They could, however, have different coefficients. So when we look to see if terms are like, that's saying do they have the same variable? And that variable, does it have the same exponent? All right. And then actually we need to fill this in. So this little line here, the x squared and the y, those are our variables. All right, so now we can look at these examples and say, are the following like terms or unlike? So here we have 3x and negative 7x. So we do have the same variable, and that variable does have the same exponent of 1, so those would be considered like terms. Next example, 6w and 8y. We have different variables, so those cannot be like. Here we have 8y squared, 2y squared, and negative 3y squared. So the variables are all the same, and the exponents of those variables are all the same, so those would be like terms. The numbers 5, 89, and 100 all have no variables, so those would be considered like terms. 4x and 4x squared, they both have the same variable, but those variables do not have the same exponents, so those would be unlike. Here we have 5 and 8x. We have no variable here, and we have one here, so those are unlike. And then the last one is we have, and here's where if there's no number in front of the variables, the coefficient is always 1, so we can just put a 1 in front there. So 1 x to the third, y to the fourth, and then 1/2 x to the third, y to the fourth. So they have the same variables after the coefficient, and those variables both have the same exponents, so those would be considered like terms as well. All right, so scrolling right down to the bottom, we have two examples where now we have all these terms written out in an expression, and we have to identify all the ones that are like. So what I would do here is I would underline all of the numbers to begin with. The ones that have no variables, those would all be like terms. So the 4 and the negative 5. And then let's start with all the x's. So here's an x to the first power, and here is an x to the first power, so I boxed those in. I don't see any others. But I do see 2x squared times y. I see 3x squared times y. I see x squared times y. Even though those have different coefficients, they have the same x squared y. So those would all be considered like terms. And then the only one that's hanging out by itself is that 3y, which has nothing else similar to it. All right, so go ahead and do example 2. Any of the like terms you can underline or box or circle, but just somehow designate and show clearly all the terms that are like for that one, and we'll check in with you tomorrow and see how you did with it. All right, so go ahead and flip over to the back side of the sheet, and now we're going to combine like terms. So we're able to look at an expression, and we're able to identify all the terms that are like, and then the last step would be to combine all those terms that are like. So when we're combining like terms, the steps would be figure out which terms are like terms, and then you would add or subtract the coefficients, also called the number in front of the variables, and then we would attach the variable or variables at the end. And we'll do some examples so you guys can get the hang of it, and then we'll have you do 1 or 2 on your own. All right, so first step is identify all of the like terms. So I'm going to go ahead and circle all the numbers that have no variables, and then I'm going to underline my x's. So now I want to combine the terms that are like. So 8 plus 13, we would get 21. And then the 7x plus 9x would give you 16x. So you would simplify that to 16x plus 21. All right, moving on to number 2. We've got the x squareds that are alike, and you want to make sure that you include the sign before the term, because that'll tell you whether you're going to subtract or add. So for example, we need to combine 19x squared and negative 1x squared, which would be 18x squared, and then we would just bring down that plus 7y squared, and that would be our final answer there. All right, let's go ahead and do example 3 together, and then we're going to have you do example 4 on your own. So here I see 3 terms that have a in it, and the a's are all to the first power. So those 3 would be considered like terms. That negative 5 is just going to hang out. So 1a plus 60a is 61a, and then 61a minus 10a gives you 51a, and then bring down the minus 5. All right, so go ahead and again do number 4 and have that ready for class tomorrow. We'll go over it, and we'll continue our algebra unit. All right, thanks a lot, and have a good day. Bye.